welcome everybody. Quick matter of introduction before we start. Like Will said, my name's Kelby Weilnau. I am the product owner of VI-NVHSim here at VI-Grade. Prior to working at VI-Grade, I spent just about 10 years in noise and vibration consulting. So I have a wealth of experience in working with automotive and frankly non-automotive cases as well, solving all sorts of NVH challenges. And so this is really a refinement of my my voyage so far in the career path as I help you now solve your NVH development challenges and move into the world of virtual prototyping with the VI-Grade NVH simulators. First, let's take a quick look at what NVH is. So NVH, noise, vibration, and harshness. It defines perceived quality, comfort, and brand character. It's a key contributor to refinement and emotional connection with the vehicle. Now, this includes powertrain sound and vibration. You can see some of the typical phenomena here. Boom, shake, growl, tonal noises from gears and motors, sort of things like that. As we get into road and noise and vibration, this ranges anywhere from secondary ride to imbalances, structure-borne and airborne road and tire noise. Wind noise, of course, is another major component. And then we have anything and everything else on the vehicle that makes sound or vibrates. Brakes, HVAC systems, chimes, warning sounds. We have AVAS these days for pedestrian warning. All of this falls under NVH. I want to emphasize that here that sound covers a large portion of these phenomena. However, vibration is a significant and key component as well. And actually, they're connected, right? Vibration and sound, especially in the perception space, they're often coupled. Also, there's overlap in the frequency space of where these exist, but the way that they interact and how we perceive them, it's not always intuitive. Sometimes we feel things in vibration and we think they're sound. Sometimes we hear things in sound and we think that they're vibration. They're often very coupled, and so it's important to consider both together when we're considering total vehicle NVH. So why is vehicle sound and vibration important? Why do we care? NVH is one of those main attributes that controls and delivers vehicle refinement and brand DNA. We think about interior and exterior components of what that means. Comfort, quality, character, they're all communicated to the driver, passengers, and observers through the sound and vibration of the vehicle. Oftentimes, the vehicle NVH is one of the first points of interaction someone has with the vehicle, whether it's in the showroom, out on the street, first time they get it and drive it. It's one of those things that's immediately connecting you to the vehicle in the way that you perceive the sound and vibration experience of that. So the buying decision, the perception of quality, reliability, whether things are functioning properly, and the emotional response, whether that's positive or negative or anywhere in between, they're all considerably influenced by the sound and vibration of the vehicle. So because NVH embraces a number of factors essential to delivering and really giving you the overall driving experience, it's really intrinsically linked to that brand DNA. We'll reference that a couple times as we go through the rest of this presentation. So of course, every vehicle has its own character, its own image, and this character and image, this brand DNA, it should be conveyed through its NVH characteristics. Now, because we wouldn't expect a Ford F-150 to sound like a Maserati or the other way around, it's really clear that there's no one right answer for NVH. It's a subjective medium. It's an experiential medium. It's something where we all bring our own sense of expectations and preferences to our interactions with the vehicle. And so it's important that as we are designing what that vehicle NVH envelope looks like for a vehicle, that we maintain some rooting in what is the essence of that vehicle. Now today, of course, there's a plethora of vehicle NVH development challenges. I'll highlight a couple here as we look towards really what the future and really even the present looks like for NVH development. Of course, electric vehicles, no surprise to see that top of this list. It's a shift as we go from the combustion engine that provides a certain degree of broadband masking, and now moving to electric motors that are really entirely tonal based elements. And it's changing the landscape of what we need to be able to handle as NVH engineers. We also need to be able to kind of preserve that historical brand sound character as we move from the combustion engine to the electric platform, making sure that we're holding on to that brand DNA as we go through. And also, we're adding sounds into the vehicle, which is kind of a new space for us as NVH engineers. We're used to reducing the noise and vibration components of what are going on, because less is always better. As we get to the point where now we've removed these things, the masking components that are actually helping us cover up some of the other ancillary noises and things, or as we're into the space of adding sounds into the vehicle, that can be a new challenge for us. Now, of course, hybrid, very much a major player in the space. We have all of the new challenges of the EV market, plus all the legacy challenges that we've been working with in the combustion engine space. So this really adds a lot of complexity for us. It's not a one set of problems or another. It's really the combination of both in those challenges. Additionally, when we talk about hybrids, there's complexity in the way that the vehicles are controlled, right? It becomes NVH is a controls problem just as much as it is understanding the sources and the paths and how those all come together. And the controls, how the vehicle is performing, how it's switching between the electric mode and the combustion engine mode or somewhere in between, is really important for us as we're considering the total vehicle NVH. And then to take that a step further, autonomous. Now, instead of focusing on the driver experience, we're now moving to a passenger experience. Now, the passenger's not engaged with the vehicle in the same way. And so the set of their expectations or what they're used to hearing or what they can accept, that's all shifting. Right. And as we go to a more and more silent sort of platform, there's other hidden NVH issues that crop up. You've got other pumps and things that you wouldn't hear normally because you're focused on the task of driving. Now, as you become the passenger, those become a little bit more interesting and kind of maybe distract you from the book that you're reading or the puzzle that you're working on. And we want to make sure that we're designing for the proper experience from the NVH standpoint. Additionally, sound design, which I referenced in the EV topic, that's one of those things that can control and help set the stage for what the comfort interior while the vehicle is in operation, what that looks like, as well as the brand perception, right? You get into a particular brand of autonomous vehicle, that's an opportunity to have sonic branding that makes it so that differentiates your experience from the number of options you might have in that space. Lightweighting, that's not new. That's always been a challenge for us in NVH. The mass targets are always low, 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 which is great for economy and performance. Not always so great for NVH. A lot of the times mass is king in treating NVH problems, but that's not always something we can get away with, and especially it's made a little bit more prominent by the EV space and all the range considerations that go into needing to manage the overall mass and the lightweighting architectures of things. And then, of course, as physical prototypes become harder to get to, going away entirely, or are being removed based on cost reasons or needing to go faster, where there's increased reliance on simulation. If you don't have access to the prototypes, you still need a way to make your decisions confidently. And that's in a big way, that's what we're here to talk about today. Which brings me to, we have a need to be able to simulate and experience vibration and sound together. A couple pages ago, when we're talking about the frequency ranges that vibration is present in, sound is present in, we've got that overlap region. Because of that complexity in the perception of how we kind of take in that information of sound and vibration, it's important that we can simulate and experience both of those together on a common platform to make sure that we've got a comprehensive view of what the total vehicle NVH is. And this is something that we'll talk through quite a bit as we go through VI-NVHSim and its applications with the various NVH simulators we offer here at VI Grade. So many types of engineering data and CA analysis can be adequately expressed, experienced, and understood visually. So if we look at things like the crash test here in the simulation that goes with that, it can be very easy to extract the sort of pass-fail behavior of the device under test with that sort of evaluation. However, when we move to NVH data, we get a lot of plots and graphs that we can look at. And as experts, we can interpret these, we can read these, and we can extract some insights, some value from that and understand what is going on. But it requires a particular level of expertise, and oftentimes the plots are not comprehensive in the way that they deliver really what the NVH experience is. We can look at the numbers and the plots and the graphs. They're useful. They can tell us things objectively. That's, of course, interesting to us as NVH engineers, but it doesn't answer questions like, does it sound good? Is it better than the competition or the previous generation? What does it sound like? How does it feel? These sorts of things, we can't answer those with plots and graphs alone. And so we need a way to be able to bring these data to life, bring that to experience, so that we can really, truly, deeply understand what the NVH reality of our particular phenomena that we're chasing is, right? And so to address this, we created our NVH simulators and VI-NVHSim here at VI-Grade. So with the NVH simulators offered by VI-Grade, what we do is bring your NVH data to life. So while we're exercising virtual prototypes, you have full control over the vehicle. You can drive it just as you would a real car with accelerator and brake pedal, steering, and gear shift. The models that we use can be constructed using CAE simulation data, test and measurement, or often a combination of both in order to return the complete experience of your NVH data at any stage of your development process. So during the evaluation, it's possible to change sounds back to back on the fly while we're driving. This allows us to change between vehicles, vehicle components or configurations, allowing us to confidently compare and judge any aspect of the NVH performance. Through these evaluations, we can also collect subjective ratings to understand subjective preference, allowing us to refine the vehicle NVH and achieve our vision for the future of what that vehicle platform really should be. The sound of the vehicle can be represented as several components, such as motor, engine, road, and wind noise, and can be further subdivided into individual sources and paths, leveraging transfer path methodologies from test and measurement, CA simulations, or again, a combination of both. The VI-NVHSim software is used to develop new vehicles and new vehicle sounds, where we can apply filters to change the sound of the vehicle, change the motor, gearbox, engine, exhaust, tires, and other components. The NVH simulator is an ideal environment for active sound design, designing and integrating electronic sound enhancement. Now, there are several versions of NVH simulators at VI-Grade, all powered by the same core VI-NVHSim software. The desktop NVH simulator is the primary workstation for standalone usage, as well as feeding the larger simulators. The compact NVH simulator adds vibration as well as sound. We also have options for the on-road simulator and exterior sound simulator as well. This allows us to listen to the sound of the vehicle before we build the car. We can capture customer preference and learn from that, communicate our design changes effectively and efficiently through experience, reducing the need for physical prototypes so that we can understand our NVH data quickly and easily, allowing us to make our decisions with more confidence than was ever before possible. So now that we've seen that, let's dive a little bit into some of those individual components. I'll start with VI-NVHSim as the overarching umbrella, again, that being that core software that powers all of the solutions, and then we'll dive into some of the individual use cases as well. One of the ways I like to look at VI-NVHSim is as a data integrator. We have to be able to pull data from multiple sources, whether that's CAE testing, our involvement as humans in our evaluations, and we need that to be in a single interactive environment. And that's what VI-NVHSim does every day, bringing those together so that we can drive, listen, and compare our NVH results in the virtual space. So the NVH simulator can bring together data from multiple sources into a single unified virtual prototype. This can include vehicle measurements, component or test bench measurements, CA data simulations of many different types, all of that brought together into a single model so that we can evaluate it comprehensively. That allows us to drive it, experience what that is like, understand the NVH truth of what we have, and make decisions with confidence, because we're making those decisions in the same way that we would have done with the physical prototypes. This allows us to then communicate the information to the decision makers and those who need to know. And really, it's very useful as a demonstrator to be able to prove, okay, why do I need to make this change? Am I going to appreciate that level of change? Is the target set in an appropriate level? And these sorts of things are much easier to make judgments on when you can actually experience it for yourself. You're not having to do the translation from the plots and graphs into that level of understanding. It's a lot easier to show people than it is to explain. So why would I want to shift from testing prototypes into virtual development? Well, plain and simple, prototypes are going, or in many cases have already gone away. That's being done for reasons of we need to be able to be faster to market. Well, the prototypes cost is significant, so we're trying to keep costs of the development programs down. So plain and simple, there are no prototypes, or if there are, they're only available very late in the development process. Now, NVH being experiential, oftentimes the first opportunity we really have, even in the traditional process, to judge an NVH representative prototype is, again, late in the development process, late in the game. That's challenging for us in NVH because, as we know, when we're solving noise and vibration problems, the closer we are to treating the source, the more effective we can be. Late stage changes, they're much more expensive and in many cases less impactful or less effective than if we were able to make effective changes early in the design process. And so by moving to virtual development and enabling the experiential simulation of the actual NVH data that we have at all the various places in the development process, that allows us to always be evaluating from that context of what will the end user, that customer that's going to buy the vehicle, what are they going to experience, and making sure that we're locked in and anchored on that particular point. So all in all, virtual development for NVH, it's faster, it's cheaper, and it's less risky than traditional physical prototypes, provided, of course, we can have that touch point of the experience in a realistic manner, which is, of course, what we're here to talk about today with VI-NVHSim and the NVH simulators from VI-Grade. As evidence to that, how we can be using virtual development in the modern development process, I have here a case study from Ford. Ford was working to develop this new Puma Gen E electric vehicle platform, and their challenge was making sure that they had something that was representative of their brand DNA, and also being able to do that quickly, right? They didn't have access to prototypes along the way. They needed a way to be able to make those sorts of evaluations, make those choices, and understand what the reality of their NVH progress was at every step of the process. The way that they did that was they utilized the desktop NVH simulator to bring their CAE results to life, allowing them to understand what the NVH behavior of the vehicle was going to be before it was built, as well as bringing in sound designs done in the sound design partner tools, bring those in and virtually refine their propulsion sound concepts before they built a single prototype. What this did for them was it enabled them to get same-day design assessments. You run the CAE model, you immediately have the results that you can listen to and experience. They could bring in management for reviews. They could help refine their CAE predictions to make sure that that was correlated to what they expected from the target levels. And all in all, at the end of the day, they were able to perform 75% of their sound tuning in the simulator rather than spending time in mock-up vehicles or physical prototypes, which saves them a whole ton on the cost front. So another use case of virtual development for NVH that I think sometimes gets overlooked is to be able to build a library of virtual models that can be continually referenced. If we think about the traditional approach, where we might maintain a fleet of vehicles, these are naturally going to age. They need to be maintained. They need to be stored somewhere. They need to be accessible. However, as we move into the virtual space, we can essentially bottle these benchmark vehicles and have them virtually accessible at any time, at any place on the globe. This means it's much easier to be able to do the target setting sort of exercises that we have by recalling any particular vehicle that we may have measured in the past and use that in our evaluations as a reference point for our virtual prototype development. That means we always have a way to get back to it. And even it means, because of the modular nature of these NVH simulator models, means we can recombine things and borrow, as we're setting future direction, road noise targets from a particular golden benchmark, let's say, and the same thing with powertrain, and build a best of the best sort of target virtual vehicle that we can evaluate and use to drive the early stage developments of the platforms. This also, with that A to B sort of comparison workflow, that's enabled by the virtual development very easily, because like we saw in the video, you can switch between the vehicles on the fly. You don't have to get out of the vehicle as you would if you were to organize a physical drive, get out of one vehicle to get into the other, get to the same place on the track. We can do that all virtually, allowing you to more quickly bounce back and forth between those and make the judgments even more confidently than you could with the physical vehicles. I'm going to put this slide up here to show that really VI-NVHSim and the NVH simulators at VI grade were a proven solution. The VI-NVHSim software has been actively developed over the last 20 plus years, and it continues to be so as the development needs continue to evolve, and we continue to push further into this space of virtual development. You can see that we've got a global presence across many of the major automotive OEMs, and even down into the supplier level. And it's used and trusted by these automakers to be able to deliver a better NVH in a faster manner. So the NVH simulator technology can be applied in several ways. As we saw in the video, it goes anywhere from the core VI-NVHSim software up through the various simulators and the various workflows, including the on-road and exterior sound sim. So let's kind of step through these and look at these in more detail. Starting off with the VI-NVHSim software, again, this is the core of all of the solutions. It powers everything that we'll see from here on out. So no matter where you're introduced to the NVH simulators, there's no learning curve as far as the software is concerned, because as you move between the desktop NVH and the compact, etc., you're working with the same platform. That really, it makes it much easier to adopt this within your workflow, because you're not having to relearn it every time you add new functionality. Again, it's all powered by the same core software. Key capabilities that we have here, being able to build our virtual NVH prototypes from CAE or test data, or a combination of both. Oftentimes that hybrid modeling is where people are. We know that CAE results are traditionally band limited in frequency. Test data is great because it's full bandwidth. And really, you can get the best of both worlds by taking a hybrid approach and using the CAE data where it's applicable and filling in the gaps with test data from surrogate vehicles or modified versions of existing models. We can compare and tune the results in real time. So that's flipping between the various vehicles or configurations, swapping out components, being able to swap back and forth of those in real time. Really useful. Also, you saw in the video that we can apply filters to the sounds to do what-if analysis or try to understand particular elements of the NVH phenomena. We can experience the sound and vibration anywhere from the desktop to a full simulator. This is something where the software here, I've got it shown running on a laptop. Even when we talk about the desktop NVH, that's something that laptops these days certainly are well equipped to be able to run this software suite. And that means it's also portable to the point where if you have a global presence and you need to be able to share models between sites, it becomes very easy to do so with the VI-NVHSim software, sharing models between a North American facility and one in Europe, for example, or even in Japan. So further to that, of course, being part of the VI grade umbrella, VI grade offers many softwares across vehicle dynamics, noise and vibration, and HMI and ADAS. And it's fully integrated with all of those software tools to allow for software in the loop, hardware in the loop, anything in the loop. That's our XIL sort of platform in there, depending on what you need, sound placed where, or you need some other sort of computations brought in. We'll talk more about that as we get in. What does this mean for you? You can bring your data to life, transforming that NVH data into something you can experience and really truly understand. It allows you to validate faster those CAE models because you get that real-time interaction. You can apply filters to really set direction and give feedback into the CAE teams so that they can iterate on the models and bring those closer to what they need to be for design intent. And then the ability to collaborate seamlessly across teams, with it being easy to share models across the globe, becomes that you can really package up even a competitive benchmark and share that globally so much easier than it would be to ship vehicles all over the place. So again, the desktop NVH simulator, that's our basic workstation. We can do anything that we can do on any of the major simulators. The simulators just provide different avenues of bringing different elements of that to your experience. The desktop, of course, from a playback standpoint or what you can experience, that's done just from an audio standpoint. As we move up into the other simulators, then we bring in other attributes. But the reality is, within the model structure, whether we experience it or not, we have access to those vibration data. We can use those in offline analysis or to help guide our understanding of what is going on within our models. So this brings me to my next case study. So this is coming from BASF, which is a component supplier for the automotive market. Their challenge was they have these new mounts made of composite materials that are designed to replace traditional aluminum or metal powertrain mounts. What they need to be able to do is prove to their customers, the automotive OEMs, that the NVH performance is comparable or better than what the traditional mounts are. There's also other values to moving to composite mounts from the standpoint of lightweighting or cost implications. And so it's important to be able to understand what does that mean for NVH. And so this is where bringing the data to life is really critical for them because it allows them to demonstrate what the capability of their parts are in the total vehicle system. So the way that they did this is they took source path contribution analysis and our NVH simulator models and brought those together to be able to really kind of isolate the structure-borne and airborne components of the powertrain as it goes through its various modes of operation in real driving conditions, and then really kind of propagate that to what does the driver feel and hear with regard to these mounts. This allowed them to demonstrate that the composite brackets were as good as the metal aluminum mounts from an NVH standpoint in electric vehicles, while also having the added benefit of significant mass and cost reductions. So it gives the OEMs some sense of confidence that when they put these mounts to their vehicle, that it will be returning the value that they need, and they don't have to worry about, oh, we're moving to an alternative mounting strategy that's going to degrade NVH performance. Well, in this case, we don't even have to rely only on the plots and graphs that say, hey, things are the same. Now also the OEMs have a chance to learn from BASF, hey, these mounts are actually the same performance, and I've experienced it for myself virtually before I sign that contract and say, yes, okay, we're putting that into production. So moving up in the complexity of the NVH simulators at VI grade, our next step up is the compact NVH simulator. This is the first simulator of its kind in the automotive industry to be able to offer both calibrated sound and vibration together on a common platform. So the key focus of this one is adding that vibration content. It's calibrated vibration at 7 independent degrees of freedom. So that is, we've got 3 degrees of freedom on the seat in vertical, lateral, and fore-aft directions. We've got 2 degrees of freedom on the steering wheel at vertical and lateral directions. And then also the footwell or heel point has vertical and lateral vibration excitation as well. This combination means that we are delivering vibration to all of the places on the vehicle that you as a driver are touching, meaning that we can produce for you the entire realistic, calibrated vibration spectrum, as well as the calibrated sound that we're known for with the desktop NVH. So bringing all of that together allows us, as we saw in that early slide, that overlap region where we have sound and vibration interacting. The compact NVH simulator allows us a platform where we can really deep dive and understand those sorts of interactions in the virtual development space. Then we've even taken it a step further, leveraging the side of the business that deals with ride and handling and vehicle dynamics, and we're offering the compact FSS or full spectrum simulator, which adds to the compact NVH platform of sound and vibration. It adds motion to that. So now we have overall vehicle motion, adding that in to the equation so that we are starting to simulate more and more attributes of what the vehicle does. This starts to allow the vehicle dynamics teams and the noise and vibration teams to collaborate together, especially in that low frequency range where it's really important to understand the trade-offs of making a choice that prefers NVH or prefers vehicle dynamics. What effect does it have on the other domain? This is one of the simulators that we have in our full spectrum line that gives a common platform for those teams working together. Similarly, we take that up another degree and add that same technology, that full spectrum simulator technology, into a driver in motion platform. So now we have overall vehicle motion, 9 degrees of freedom introduced in addition to the calibrated vibration and full spectrum sound that we offer with the NVH solutions. Bringing it to the on-road application, this takes our desktop NVH simulator powered by VI-NVHSim and brings it into a physical vehicle. Now, we've talked about virtual prototype development. Why am I bringing in the physical vehicles all of a sudden? Well, there's certain elements of modern NVH in which you really want the context provided by being able to drive around in real world scenarios, but you need the flexibility of virtual development in the way that you're making tuning changes or adjustments to those. Sound design is a classic example of this. If I'm adding in powertrain sound enhancement, or I'm doing things for exterior and pedestrian awareness, I want to be able to put that on a mock-up vehicle, whereas the simulated content is really the things that I'm adding to the vehicle. So it gives it a realistic context, gives me the ability to drive it in a real-world scenario, but I still get the advantages of virtual development by having VI-NVHSim running in the vehicle, so I can make those real-time adjustments, apply filters, and change between designs on the fly. Really useful as we're in the sound design space. Now, of course, everything that we can be doing for interior sound can be extended to the exterior of the vehicle as well. The exterior sound simulator module enables that experience of exterior sound of the vehicle under various operating conditions in the presence of different types of ambient noise, different levels of traffic, all from the viewpoint of a stationary or a moving observer. So if we think about the pedestrian viewpoint here, that's what we're talking about, especially in the space of electric vehicles and the AVAS, the pedestrian warning sounds. This is particularly interesting to make sure that in the context of the exterior of the vehicle, we're maintaining a link to that brand DNA, making sure that every element of what the noise and vibration signature of that vehicle is reflecting the quality and the essence of what character we want that vehicle to provide. Which brings me to another case study, this one from Subaru, where they were using the NVH simulator to understand customer preference. They were setting directions for future sound design implementations, future really sound concept type directions. And what they wanted to do was make sure that their NVH development targets were aligned with what their customer preferences were. The way that they did this was they used VI-NVHSim and the desktop NVH simulator running jury studies so that they can collect subjective feedback on various vehicle concept sounds. So they allowed the jurors that came in, and these were representative of the customer market, come in and drive the simulator as they would the actual vehicle, but allowed them to drive some real and virtual vehicles in VI-NVHSim so that they could understand what these customers liked, what they didn't like, and help confirm direction from an NVH target standpoint. What this allowed them to do was truly understand their market, make sure that they were designing sounds that were going to make the people that they're targeting with these vehicles happy, make sure that they didn't have to go through extensive validation loops when they were getting to the tuning implementation of the vehicle and get lots of feedback at that point that changes their direction that they need to pivot from. They could set all that up front, make sure that their targets were aligned, and then chase through their normal development process, ultimately resulting in higher customer satisfaction. All right, and then to wrap up some of the simulator offerings, I want to mention VI-Sim Sound. It's another software product as a part of VI Grade's NVH simulator product line. This is really it's kind of a companion project or companion product to VI-NVHSim, where we take purely the sound generation capabilities of VI-NVHSim, and we make that something that can be installed on any dynamic driving simulator. And so this is something that's running every day in our driver in motion simulators, but also we have customers using this on various driving simulators to be able to add realistic immersive audio into that driving simulator. The important thing to talk about SimSound is it's not that the simulator sounds like a car, it actually sounds like the car. Even if you're not evaluating NVH directly, having that level of immersion is really important to make sure that people are accepting what they're getting out of a simulator. All right, so back in with the NVH topics, sound design. And when we talk about modern NVH, I think there are three major pillars. Those three being CAE simulation, test and measurement, and sound design. I think the modern NVH engineer has some involvement with all three of those. And so with that in mind, we've made sure that VI-NVHSim is partnered with some of the major players in the sound design space so that we can do software in the loop, virtual development, and then allow for a seamless transition from those virtual prototypes to the in-vehicle implementation using, again, the target software and hardware that will be going to the vehicle, but we allow to bring that early in the development process and interface with the virtual prototypes exercised in VI-NVHSim. Now, when we talk about brand identity, brand DNA, Ferrari's got a factor in there. They're the perfect story for this. The challenge for Ferrari is, of course, they have an unmistakable sound. It's very identifiable. It's a core element of their brand DNA. They need to be able to preserve that in new and future vehicles. but they need to also be able to meet the increasingly strict noise regulations that we have for controlling the environmental noise. So what they did was they leveraged the desktop NVH simulator to take multiple intake and exhaust designs and iterations and evaluate those virtually so that they could make sure that at every step of the process, they were anchored in the brand DNA of what sounds and feels like a Ferrari. It's very important for them to be able to do that, and they were able to easily iterate through these designs by leveraging the desktop NVH simulator and VI-NVHSim, doing this all virtually so that they know when they build that first prototype that it is matching that brand identity that they have and maintaining that key character that they need authentic to the brand that they are. So then let's talk a little bit about where we get those various sources of data. We talked about sound design. Let's get into the other couple of pillars of modern NVH. So starting out, CAE results and data, this is vital. When we talk about modern vehicle development, there's no component that doesn't at some point get virtually modeled with CAE. So to that end, we've worked together with several CAE suppliers to make sure that it's easy to bring CAE results into VI-NVHSim and the NVH simulator environment and utilize these in our virtual prototypes. This is a small list here, but the reality is, as we go into the broader conversation of what does it mean to have data that comes into VI-NVHSim, we're wide open on this. Across test and measurement, CAE, and sound design, we make sure that we always have an open option. So any amount of data that you're already working with in your existing processes for vehicle development, those data can immediately be used and brought into the workflow. Now, of course, being that our final target here is experiential simulation, everything, all roads lead to time data. So ultimately, time data is what we're using and experiencing at the output of VI-NVHSim. But not every data source is originating in that time data sort of format. And so some data needs some preparation to be able to get there. We have a suite of data preparation tools to be able to take, whether it's test and measurement results or CA data simulations, and get those formatted in such a way that we can build up our NVH simulator models. Now, I talk about time domain. I want to be very clear here. During the runtime of the simulation, we're not simply playing back data, although that is a component that is possible to do within VI-NVHSim. We're actually resynthesizing the data based on how we've prepared it, how we've cataloged it, and how it behaves in response to various vehicle parameters so that we can give you something that is responding to your driver inputs. And so to enable the ability to freely drive these virtual models, the data preparation process allows us to catalog our data so that it responds. As you press the pedal and the vehicle accelerates, we get the sweep of the RPM data, we get the increase of the road and wind noise. It's all very natural. It's all tied into exactly how that data truth is. We're not making up anything here. We're giving you back what you have provided as inputs to the model. But we're doing it in such a way that it's interactive. That means you're not locked into the same operating conditions that you've characterized through your CAE simulations or your test and measurement. Actually, if you provide a whole range of those operating conditions, we can on the fly be swapping between those and make sure that you can exercise the virtual vehicle in the same way that you would the physical vehicle at the end of the day. So that brings me to another case study, this one from Hyundai, where they used our open CAE formats to leverage the sort of CAE simulations that they're running with the experiential benefits of using VI-NVHSim in the loop. So they had a challenge where they were in the unfortunate circumstance of having to improve their road noise performance late in the development process. And so you might say, oh, well, you've already got prototypes, go out there and start mocking up countermeasure changes on the prototype. Of course, that's an option, but you can always go faster when it comes to virtual. And when you're late in development and up against a deadline, going faster is really important. And so they also needed to make sure that this was balanced with their ride and handling, their vehicle dynamics targets, and their existing NVH targets. And they want to do this quickly and confidently. So enter in VI-NVHSim and the NVH simulators from VI Grade. They were able to take their hybrid test and CAE modeling approach and bring that into the compact NVH simulator in order to evaluate virtual changes to the suspension geometry and the attachment point stiffnesses. They could do that objectively and subjectively, meaning that they can monitor where are they with regard to their NVH targets, as well as do that feeling check of, okay, when I make this change, directionally, is it moving me in a spot that is improving the overall road noise performance in the context of everything else that's going on in the vehicle? By leveraging this approach, they were able to optimize the results very quickly, of course, rerunning their CAE analysis to change something about the stiffness injection that they're doing, but also bringing that to life so that they could, at every step of the process, confidently know where they're at relative to their targets, both objectively and subjectively. So one of the elements of bringing data to life is to enable this free driving, so the driver in the loop sort of methodology here. To enable this, we need to have some way of modeling inputs as the pedal positions, start, stop, steering inputs, things like this, and how that affects what the vehicle actually does, which drives our NVH model. We have multiple avenues for doing this within VI-NVHSim, including performance data models that can be built from test and measurement data, essentially taking speed and RPM curves at various pedal applications so that we know how fast the vehicle should be accelerating or decelerating at any point during the simulation. Further to that, we can get a little bit more specific, especially when physical vehicles aren't always available, and do things based on physics-based performance predictions, considering the physical attributes of the target vehicle and making sure we have something that can translate those driver demands into RPM, speeds, loads, things like that. And then really the ultimate is the model in the loop approach, which is supported by the NVH Simulator Universal Plugin Network API, which allows us to connect in software in the loop or hardware in the loop real-time performance models, for example, hosted in MATLAB Simulink, or leveraging another one of the VI grade solutions, VI Car Real Time, that's well suited for this sort of performance model prediction, and using that in tandem with VI-NVHSim, bringing our NVH data to life in the context of the complex control systems that we have, especially in the hybrid electric space. It's really important for us. And so having that sort of model in the loop approach really enables us to focus as NVH engineers on the components we can control, but also bringing in the realism that we need from other elements of our vehicle development. So to that end, when we talk about software in the loop, that's really any other software calculation that could be running to simulate some aspect of the vehicle performance, whether that's the performance model in the loop that we just talked about, sound design in the loop, or really any application. If you've got some sort of control system that you're trying to understand, how does that change what the driver's behavior is? Well, we have a virtual prototype that we can drive realistically, and we can have this control loop going that maybe plays some chimes or does different things to help interact with what the driver experience is. Similarly, with hardware in the loop, we've got many avenues of being able to connect with driver controls or the physical vehicle itself. We actually have a couple customers that are interacting with actual kind of product dynamometers, where they can pull signals off of that and use that to influence the simulation, or even putting vehicle electronics in the loop. When we think about performance modeling, that can be a component. Also, when we talk about sound design, having the actual physical amplifier running its own set of software and just receiving CAN inputs, that's a possibility, leveraging the virtual vehicle in VI-NVHSim. So of course, with VI-NVHSim being a component of the VI grade software suite, it's well integrated with the other VI grade solutions across vehicle dynamics, HMI, and ADAS. And that includes, of course, our visual scenarios in VI WorldSim. It's important when you're driving something virtually that you have some sort of a touch point of where are you in the world. That's where VI WorldSim comes in, providing high quality graphical environments so that you know where are you on the road, how fast are you going, and you have some sensation of that as you're evaluating the vehicle NVH. So then finally, before we wrap up here, I have one more case study to share with you, and that is coming from Stellantis, where they're well integrated into virtual development, leveraging VI-NVHSim and the desktop NVH simulator. One of their goals, their challenge, is to be able to manage across the globe. You look at Stellantis, they have brands across the globe, lots of different platforms there. They want to make sure that they have consistent NVH performance that is tied in with their own brand DNA, while also reducing their dependency on physical prototypes and making it just generally easier to work in the NVH space. So some of the ways that they've done this is actually leveraging component-based models, being able to swap out powertrains wholesale or test new mounting strategies or snorkel designs, and assess what impact those will have on the total NVH performance. This also allows them to be able to share those models across the globe so that it becomes easy for stakeholders, no matter where they are, to make judgments on what the latest developments are for their NVH platforms. This allows them to really enhance their correlation between their CAE models and what they're getting in the test and measurement world. They can iterate faster and they can work globally in order to make sure that they're solving and monitoring their status with regard to their NVH performance and their brand DNA. So to summarize, with the NVH simulator offerings from VI Grade, you can experience your NVH data to make efficient, confident, and quick decisions in order to be highly effective and reduce cost in overall your vehicle development programs. And with that, this is our call to action. If you've liked what you see today, I'd have you follow this QR code, request a demo. Experiential simulation, always tough to do these things online because really the best way to do it is for you to sit down and experience it for yourself, so you can really see the true power of using virtual development for NVH so that you can make those better NVH decisions faster and with more confidence. So with that, we'll open it up to Q&A. Thanks very much for your attention so far.
Thanks very much, Kelby. Great presentation. It looks like we have just under 10 minutes left for Q&A, so we'll jump into it right now. Just a reminder to the audience, if you want to put forward a question, you can do so by submitting it by typing on the Q&A box. That's the two overlapping speech bubbles you'll find located at the top of your screen. The first question here, Kelby, asks for suggestions or a way forward for the Pakistan market. It's quite a broad question, so take it wherever you want.
Oh, sure. And of course, if you're here and you want to get a little bit more specific with that, I'll take that. But this is an opportunity for me to say, while I don't have direct experience with that market, what I do know working in the global scenario is the preferences of everyone across the globe tend to be somewhat region specific, right? If we think about the Subaru project that I talked about with the case studies, one of the things that they were learning was the customers they have in Japan versus the customers in North America have different senses for what they think an exciting vehicle NVH experience could be. And so being able to leverage virtual development and learn from the customers what their preferences are, really important to make sure that you're tailored to the various markets. Now, of course, I'm sure there's some of the challenges that I've posed today that are global, right? They cover everyone, and then some may affect more others than others altogether. But I think the premise of virtual development and being able to experience for yourself what the NVH truth is of the data that you're analyzing day to day, that's one of those kind of global sellers that it provides value to you no matter where you are on the globe.
Now, this next one's a two-parter. The first part, how can you best mitigate sound quality loss via the audio system that degrades the simulation output when experienced? And secondly, can you calibrate and model the limitations of the audio system and then compensate?
Sure. So all throughout this, I've mentioned a couple times that it is calibrated and validated playback, or experience. Playback's a little bit of a coarse word to use in this. Like I said, we're not just directly playing it back. It's resynthesis. But the essence is when we talk about calibration, that's really kind of ironing out those inconsistencies that we might see in the audio system playback and making sure that that is equalized in a way that what you are experiencing is the model truth directly and not colored by the headphones or the loudspeakers that you're using for that sort of playback. And the same thing extends to the vibration simulators of the compact NVH, et cetera. We actually have calibration routines where you can measure whatever audio hardware that you're using and develop these equalization curves so that you can ensure flat calibrated response in what that is. And that's a standard part of the workflow of using VI-NVHSim across any of the simulators that we have here at VI-Grade.
Says a good adoption of this area of engineering appears to require the mapping and correlation of real-world measurements to the subsystems of the source of the noise and vibration, and that this is before we discuss cross-coupling and resonances. Their question is this the source path contribution analysis that you mentioned?
Yes, exactly. I mean, there is always some degree of correlation, even when we talk about pure CAE simulation, having some kind of rooting in reality can be important for making sure that we're using that data effectively. Now, of course, one of the challenges in working with pure simulation data is it's very good at predicting a change, but may not be as easy to achieve absolute correlation. And that's where using both test-based methodologies like the source path contribution analysis and the CAE approaches allows us kind of the best of both worlds. You can use the CAE analysis to set the directional changes of a particular countermeasure application and then apply that to something that you've maybe is a little bit more easy to achieve absolute correlation with a test and measurement based model. And then you get the ability to predict what that change would be, experience what that change would be, but you're not worried about trying to make sure you're chasing your tail on absolute correlation of a CAE model where that's not really where you should be spending your time. It's better for you to make sure that you can get to the point of making the judgment in a confident fashion.
Someone would like to know whether what you've been discussing today can also be used for non-mobility projects.
Absolutely. Like I said in the intro, before this in consulting, I worked in automotive and non-automotive. Because of the way that this system is architected, technically anything that's rotating machinery is well suited for simulation in this space. Just in the way that we kind of assemble those building blocks together, or really even as a subjective assessment tool. If I've got some compressors running in a room and I want to experience what those are back to back, the same sort of methodology applies. So really, anytime you need to bring noise and vibration data into the experiential space, something like VI-NVHSim is well suited for that.
And I think we've got time for one more. How is NVHSim modal data verified with experimentally obtained data?
Oh, that's a great question. So with the virtual prototypes, we still give you the ability to extract from that anything you would if you were to make physical measurements of a vehicle. We actually have a built-in data recorder in VI-NVHSim that allows you to, at any point of a free driving or a kind of scripted type scenario, record the output of what that is. That allows you to then take that and directly compare it to test and measurement data that you might have from the vehicle that you're building up if you're doing a benchmarking vehicle, or get it back from the experiential into the data source of it, so you can make direct data comparisons objectively between maybe the root CAE data that you use to build the model and what you're getting as output of the model, always with the mind of being able to validate or even extend that once it's validated, push that into target management, let's say, and being able to evaluate in the same way that you would with the traditional methods of test and measurement, get that output data that you could use and analyze from the virtual models as well. So yes, typically what we do is make comparisons between the virtual simulation outputs and what our reference is, whether that is in the frequency space, just judging versus target, or judging versus the original measured data that was used for a benchmarking based model. All depends on really the stack of that model. But because we have that recording output capability, you get access to everything along the way so that you can make those sort of comparisons. And if you need to make adjustments, then it also gives you the mechanism for doing that. The filters that I showed in the video, those are good for what if scenarios of trying to make design changes, but it's also useful when you need to make slight adjustments to the model contents to bring it more in line with what your expectations are.
And looking at the clock, looks like our time is up. So unfortunately, we'll have to bring the webinar to a close. From Mobex, I'd like to thank Kelby for sharing his insight with us, VI Grade for making the event possible, and of course, our audience for joining. There will be an on-demand version of this webinar available for you to watch as soon as possible. But for now, thank you so much for listening, and goodbye.